Hello guys, welcome to Physics Unlocked, and I'm here with a very interesting problem of physics taken from INPHO 2006. So in this problem, we are given a uniform disk of mass 2m and radius r, and there is a block of height 2r, height is 2r, and it is of mass m. Both of this disk and block is placed on rough surface. So there is a coefficient of friction. There is a friction between this disk and surface as well as block and this surface, and we are given the coefficient of friction between these surfaces is mu. So coefficient of friction between these two surfaces is mu, as well as here coefficient of friction is also mu, and there is no friction between these two surfaces. That means there is no friction between disk and block. Initially, the disk is having a angular speed of omega naught about its own axis in this sense. So the bottommost point of the disk will have a speed of omega naught into r in backward direction, due to which it will slip in backward direction. So to prevent this slipping, there will be a limiting friction that will act on this disk in forward direction at this point. So 2 mu mg of friction will act on the disk in forward direction. Due to this friction, the disk will try to move in forward direction. Due to which there will be a normal reaction in leftward direction, and the same normal will act on the block in rightward direction, due to which it will try to move, and to prevent the slipping, the limiting friction will come at the bottom of this block. So if we write the equation of motion, so the net force on the disk will be mass into acceleration, as well as for the block the net force will be mass into acceleration. So if we add these two equations, the value of the acceleration will be mu g by 3. So this is the answer of first part of this problem. So the initial acceleration of block disk system will be mu g by 3. Since they are in contact throughout, that is why we have assumed that they are moving with common acceleration of a. Now in B part, we have to find t star at which pure rolling starts. So for the time t less than t star, there is no rolling, there is no pure rolling. So the bottommost point is slipping in backward direction, because the velocity of bottommost point will be in backward direction, because it has no linear velocities. So only angular velocity about its center will give the velocity to this bottommost point in left direction, due to which it will try to slip in left direction. So the limiting friction at this point will act in forward direction of 2 mu mg. So if we write the equation of motion, force will be mass into acceleration. Similarly here, force will be mass into acceleration. Adding these two equations, acceleration will be again mu g by 3. For the whole time t less than t star, this system will move forward with acceleration of this much value. Now if we write the torque equation about this center of the disk, tau cm will be I cm into alpha. Tau cm will be 2 mu mg into r, that will be I cm into alpha. From here we can find out the alpha about the center of disk. So this is the alpha and this is the acceleration. If we look at disk, the disk has acceleration a and alpha in this sense, and it has angular speed in this sense. So due to the alpha, its angular speed will decrease, and due to the a, its linear speed will increase. So there will be a time at which v will be omega into r. So we have to find that time. At any general time t, the velocity of disk can be calculated. Since initially disk was moving with 0 speed, so u plus at, so simply the velocity of the disk will be at. A will be mu g by 3 into t, so this much speed at any general time t. Similarly, we can find out the omega of disk as omega naught minus alpha t. Since the sense of alpha is opposing the decreasing the value of angular speed, so minus of alpha will come here. So omega naught minus 2 mu g by r into t, it will be the angular speed at general time t. Now for pure rolling, v must be equal to omega r. So if we write v is equal to omega r and solve it, we will get the value of t star as 3 omega naught r by 7 mu g. So this is the solution to the B part of this problem. Now in C part, we have to find total time in which block comes to the rest. Assume pure rolling persists for t greater than t star. Now in third part of problem, we have to find total time. Total time in which the block comes to rest. So far we have discussed for the time t less than t star, and in this time period the system is moving forward with acceleration of mu g by 3. So at t is equal to t star, the velocity of block can be calculated as u plus at. Since acceleration for this time period is mu g by 3, so acceleration will be mu g by 3 into t star. So velocity of block will be simply omega naught r by 7. Now we will analyze for time period t greater than t star. Since at t star the disk has started pure rolling, so for this time period the disk will be rolling purely. As the disk is rolling without slipping, so this point will not have slipping anymore. So this point will have not any slipping. So static friction will act at this point. We have assumed, let's say F static friction is acting on this disk in forward direction. So if we take both of these two bodies as our system, so the net external force acting on this system is F and mu mg. So F minus mu mg will be equal to 3 m into A. This is the net force is equal to mass of the system into acceleration in forward direction. If you write the torque about the center of disk, Fr will be I cm into alpha. This is equation number 2. And for pure rolling, acceleration is in this direction and alpha in this sense. This point must have 0 acceleration. So for pure rolling, A must be equal to minus of alpha into r. So this is the pure rolling condition. If we solve this 3 equation, we will get the value of acceleration as minus mu g by 4. So as the disk has started pure rolling at t star, so after t greater than t star, our system, this system has started retarding with this much retardation. So let me assume block takes t dash more time after t star to come to the rest. So its final speed will be 0 and it is retarding with this much acceleration, and at t star initial speed is this much. So u minus at dash will be 0. From here we can find out the value of t dash as 4 omega naught r by 7 mu g. So total time that the block will take to come to the rest will be t dash plus t star, as t star is the time in which block disk has started rolling purely, and it takes t dash more time to come to the rest after disk has started pure rolling. So this will be the total time. If we add t star and T dash. So T star was 3 omega naught R divided by 7 mu g, and T dash is 4 omega naught R divided by 7 mu g. If we add these two, so the total time will be omega naught R by mu g. So this is the answer to the C part of this problem. Thank you.